Today we will be in Chapter 2, Section 5, solving linear equations with a variable on both sides of the equation. Our two topic objectives today will be to solve equations with a variable on both sides of the equal sign, including equations with no solution or infinitely many solutions, and to solve equations containing decimals or fractions. 2.5 Solving equations with variable on both sides of the equal sign. These are the steps that we will use in order to solve equations. Step 1, if the equation has fractions, multiply both sides by the LCD, which is the least common denominator. 2, use the distributive property to remove parentheses. 3, combine like terms. 4, use the addition property. 5, use the multiplication property. And 6, we will check our work. Please note that during this video I will not be checking my work just to save us a little bit of time. And also please note that these are the same steps that you used in section 2.4. And I'll write that. Same steps as 2.4. So hopefully this homework and these quizzes will actually be relatively simple in that you've already had some practice whenever you did the homework and quizzes for 2.4. Okay, so let's just dive right in to an example problem so we can see what we're doing. Let's do 2x minus 3 minus 5x equals 13 plus 4x minus 2. Okay, so step 1 says if we have fractions, we need to multiply by the LCD. We don't have fractions though. Step 2 says we need to remove parentheses, but we don't have any. Step 3 says combine our like terms. So on our left side of the the left side of our equal sign, we have two terms that have x's, so let's combine those. We have a 2x minus a 5x, and that will leave us with a minus 3x. Then we still have the minus 3, and that equals, on our right side, we have a 13, a 4x, and a 2. So we have a 13 and a 2. Those are like terms, so let's combine those. 13 minus 2 is 11. Then we still have the plus 4x. Now we need to get our x by itself. That's the whole goal here. So we have a negative 3x on the left side and a positive 4x on the right side. Now it does not matter which way you do this, but I like to keep my variables positive so that we don't have to worry about the negative signs. So I'm going to use the addition property, which is our step 4, and add 3x to both sides. By doing that, that'll get rid of the x's on this side and just leave a negative 3, and that'll equal 11 plus 7x. Okay, still trying to get x by itself, so we're going to subtract 11. Give us negative 14 equals 7x. Now we're going to use our multiplication property. I'm going to divide both sides by 7. 14 divided by 7. It's going to be a negative 2 because that was a negative 14, and that's going to be our x. Okay. Let's do another example. Both section 2.4 and 2.5 are going to be ones that you're just going to need to work through a whole bunch of problems in order to really get the hang of how to do them. Okay, so here's our second problem. We have 2 times p plus 3 inside parentheses, and that's going to equal negative p plus 10. Step 1 says we have to do that if we have fractions. We don't. Step 2 says use the distributive property to remove parentheses. We do have parentheses this time, so we do need to use the distributive property. So we're going to distribute our 2 inward. So we have 2p and then plus 6. That's going to equal the negative 3p plus 10. So we did distributive property here. Okay, now it says to combine like terms. We don't have any like terms to combine. Step 4 says addition property. So again, I'm going to be moving my negative 3p over because I want to keep my variables positive if I can. So I'm going to add 3p to both sides. That'll give me 5p plus 6 equals a 10. I'm going to subtract 6 from both sides. And that leaves me with 5p equals 4. I'm going to divide by 5. So p equals 4 over 5. Some of you might be using calculators. I really recommend just leaving it like this. This is how your homework is going to ask for it. It's going to ask for it in simplified fraction form or in whole number form. It's not going to ask for decimals. It will specifically ask you for decimals if it really wants decimals as an answer. Alright, moving on. These notes are really just going to be working through a whole bunch of problems and trying to make sure we understand the process. So, let's do another one. We're going to do 7 minus 2x plus 5x equals negative 2 times negative 3x plus 4 in parentheses. We don't have fractions, so we don't have to worry about step 1. We do have parentheses, so we do need to worry about using the distributive property. And we need to distribute this negative 2 in. So I'm going to copy down that side and then distribute my negative 2 in. Negative 2 times negative 3x will be 6x. Negative 2 times a positive 4 will be a negative 8. Next, we're supposed to combine like terms. So I can combine my negative 2x and my 5x on my left-hand side, and that'll become a positive 3x. And there's nothing else to combine. Need to get my x's by themselves, so I'm going to subtract over my 3x. That leaves me with 7 on the left, and that equals 3x minus 8. Still trying to get the x by itself. Need to add 8. That leaves me with 15 equal to 3x. Gotta get that 3 away from that x. Let's divide that 3 out. So it leaves me with 5 equals x. Now up here, if you would have wanted to, you could have done multiple steps at once. We could have combined those like terms and distributed it all in the same line, and that would have been okay. I'm doing this step by step so that you can see how the process works, and as you get more comfortable, you can do multiple steps and multiple lines. You don't have to take each line separately. Let's do another example. Try to leave that one on there for a minute. We have 1/2 a equals 3/4 a plus 1/5. Alright, we need to know what our least common denominator is in order to do this problem. So we need to think, what can 2 go into, that 4 can go into, that 5 can go into. So if you don't know, over to the side you can write out your 2's, your 4's, and your 5's until you come up with something that's until you see something that's in common with all of them. So do we see something? Yeah, 20. 20 is in common with all of those. That means 2 will go into 20, 4 will go into 20, 5 will go into 20. So that's our least common denominator. So we need to multiply both sides of our equation by 20. So we're going to have 20 times 1/2 a, and that's going to equal 20 times 3/4a plus 1/5. Okay, so remember, when you're multiplying by a whole number, it's the same thing as if you were to put it over 1. So we could have like 20/1 times 1/2a, like that. So we can cancel our 20 with our 2, which will leave us with 10a. If you don't remember this, you really need to go back to chapter 1 and refresh yourself on fractions. Okay? Same thing's true over here. We would have 20/1 times 3/4a plus 20/1 times 1/5. And the 20 and the 4 would reduce down to 5, leaving us with 15a. And the 20 and the 1/5 would reduce down to just leaving us with a 4. Okay, need to get my variables by themselves. So I'm actually, even though the 10a over here is by itself already, I'm going to subtract it over to the other side so I can keep my variable positive, because that's the easiest way to do it, so you don't get lost on your negative signs. So that leaves me with 0 on my left side, and that's okay. And that'll leave me with 5a plus 4. I need to subtract my 4, and that'll leave me with a -4 equals 5a. Divide by 5, divide by 5. So I'm left with -4/5 equals a. That's my final answer. This is one of the harder ones because it does have fractions. Chapter 1 is where we learned how to deal with our fractions. So I really, really recommend going back and making sure you're comfortable with that. And working quite a few of these problems. Just keep hitting the similar exercise button on your course compass. I'll write that down in case you've forgotten. Use the similar exercise button in your homework in the course compass site to give you extra problems. We're going to do 2 more that have fractions just so you can see how they work. Okay. And then we'll have a couple more that are slightly different problems. Alright, so here's another example, another fraction one. We're going to have x over 4 plus 3 equals 2 times x minus 2. Okay, this problem does have fractions, so we do have to multiply by the least common denominator. But there's only one fraction, so finding our least common denominator is really easy because it's just going to be 4. So we just have to multiply everything out by 4. So we're going to have 4 times x over 4 plus 3, and that's going to equal 4 times 2 times x minus 2. Okay, so we have to distribute this in. So the 4 out here times the x over 4. I'm going to rewrite it again just so it's not confusing and you can follow my next step. Again, if you don't need to rewrite this, don't rewrite it. On your right side, the 4 times the 2 is going to give you an 8, but then you still have the x minus 2 on the inside of the inner parentheses. Okay, the 4 times the x over 4, those 4's will cancel out. And that's going to leave us just with the x. And then we have 4 times 3, which is 12. And that's going to equal the 8 times the x minus 2. Now we got to get rid of our parentheses, so we're going to use the distributive property. We have the x plus 12, and that equals 8x minus 16. Let's subtract over our x, and that'll give us a 12 equals 7x minus 16. We're going to then add our 16, and that will give us 28 equals 7x. Divide by 7, divide by 7, so 4 equals x. So this one's actually a little bit easier than the one that we just did before it, because the least common denominator was very easy. It was just the only one that was there. The thing that might have tripped you up is this step right here where we take the 4 times the 2 times the x minus 2, and so you just have to remember to bring that in. Okay. I'm going to do one more problem, and then I'll give you a few more notes. Example, we have 1/2 times 2x plus 3, and that equals 2 over 3 times x minus 6 plus 4. Okay. Here is something that I'm going to tell you that's a little bit different from how some of your books, or how your book might use it, or how even you might want to use it. Right here we see we have fractions. That means we have to do the least common denominator. But if we multiply by least common denominator, it can get confusing. So what I really recommend doing here first is to do your distributive property to kind of simplify your problem a little bit before you multiply by your least common denominator. Your least common denominator. So that's what I would recommend doing. And that's what I'm going to do, and I'm going to show you that. So first I'm going to get rid of my parentheses. So 1/2 times 2x is just going to leave us with an x. 1/2 of 2 is 1. 1/2 times 3 is going to give us 3 over 2. And that equals 2 over 3 times x, which is going to be 2 over 3x. And 2 over 3 minus 6, times the negative 6 is going to give us a minus 4. Again, if you didn't know that, you can work it out to the side. And I'll even do that over here. 2 over 3 times a negative 6 over 1. The 3 is going to go away, and that'll become a negative 2 on top. 2 times negative 2 would give us our negative 4. So that's how I did that. So we have x plus 3 over 2 equals 2 over 3x, and then we have the minus 4 and the plus 4, so those just go away because that becomes 0. So right here we have a much simpler problem. So if you want to just keep going and work it with fractions, you can, and that is totally fine. If you do not like fractions and you want to multiply by the least common denominator, we can do that, and that's how I'm going to do it to show you. We have 2 and 3, so our least common denominator will be 6, because 2 times 3 is 6. So we have to multiply both sides by 6, so we'll have 6 times x plus 3 over 2 equals 6 times 2 over 3x. 6 times x is 6x. 6 times 3 over 2 will be we have the 6 times 3 over 2. The 6 will become a 3 and the 2 will go away, so that leaves us with 9. Over here we have 6 times 2 over 3. The 3 will go away. The 6 will become a 2, so that'll leave us with 4x. Got to get our x's together, so let's subtract the 4x. That'll leave us with 2x plus 9 equals 0. Subtract our 9, and that'll leave us with 2x equals negative 9. Divide by 2, divide by 2. We're left with x equals negative 9 over 2. This is simplified, so this would be the way you'd want to put it into your homework. Again, if you up here wanted to go ahead and just keep working it with fractions, you could, and that's okay. If you're comfortable working with fractions, then go ahead and do that. They have you multiply by the least common denominator to try and help you simplify it, because it is easier to work with whole numbers than it is to work with fractions in a lot of cases. But if you are comfortable working with fractions, then go ahead and do it. If you get a really weird answer or one that you don't think is right by working with fractions, then you can multiply by the least common denominator and kind of test yourself out and see if it was correct. Okay. I'm going to move on and I'm going to show you, write down some notes. So far, all of these equations have been conditional. And that means there has only been one answer. All of our equations, we've been able to work all the way through, and we've been able to come up with x equals something. And it's only that one number. That is the only answer for that equation. And so that is called a conditional equation. But there are two other types of equations that you will see. You'll have an example of each of these on your homework. So, the two other options. Excuse my handwriting tonight, it's horrible. First one is called identities. And these are equations that are true for infinitely many values of x. So for identities, it does not matter what your x value is, it's going to be true. It's going to work out in the equation. I will work an example of what an identity is here in just a moment. The other type of equation are contradictions. And these have no solution. So if they're conditional, they have one solution. If they are identities, they have infinitely many solutions. If they're contradictions, they have no solutions. And I will work an example of each of those. So here's an example. We have 5x minus 5 minus 2x equals 3 times x minus 2 plus 1. So this looks exactly like all the equations that we've been doing. All of the conditional equations look just like this. And you don't know in the beginning whether it's going to be a conditional or an identity or a contradiction. You have to work the problem out in order to figure that out. So I'm going to do multiple steps just to kind of make it go quicker. I'm going to combine like terms on the left, which will give me 3x minus 5. And I'm going to use my distributive property over here to get rid of my parentheses. That'll give me a 3x minus 6 plus 1. Okay, so I have 3x minus 5, and that equals, I can combine my negative 6 and my 1. That'll give me negative 5. So right here, if we look, we have 3x minus 5 equals 3x minus 5. Well, that's saying that we have the same thing equal to the same thing. So that means that this is an infinity, or excuse me, an identity which has infinitely many solutions. And if you want to keep solving this problem, I'll show you why. So we're going to add 5 to both sides, so that leaves us 3x, or excuse me, we don't add 5. We subtract our 3x. We subtract our 3x from both sides, which is what we would have done normally to try and get our x's together. That would leave us with a minus 5 equals a minus 5. Is that true? Does negative 5 always equal negative 5? Yes, that's always true regardless. So that tells us that this is an identity problem, and that it does not matter in the beginning. If we would have plugged in 1 here, it would have been the right answer. If we would have plugged in 1,000,000 here, it would have worked. And so that's what an identity does. You'll come out to a point where you'll have the same thing on both sides. And when you do that, that tells you it's an identity, and that tells you it has infinitely many solutions. And that's the thing you'll have to remember, because your homework problem will ask you if it's conditional, and if it is, it'll ask you to give the value for x. If it's not conditional, then it'll ask, does it have infinitely many solutions or no solutions? And this one would have infinitely many. Okay? I took this one straight off of your homework, so hopefully this isn't going to be too difficult. Okay, let's do another example. Negative 2x plus 5 plus 3x equals 5x minus 4x plus 7. Again, it's just another lame equation. It looks just like any of the others. So I'm going to combine my like terms. So you get negative 2x plus 3x. Give me 1x plus 5, and that equals a x plus 7 on the other side. Right here, we should see maybe a little red flag would pop up because it's saying x plus 5 is going to be the same thing as x plus 7. What number can you add 5 to, and it'll be the exact same number plus 7? If that doesn't make sense word-wise, let me show you. If we keep working the problem and get our x's, which is how we'd work them, we would have 5 equal to 7. Is that true? No, that's a false statement. So since that's a false statement, that means that this is a contradiction, and that it would have no solution, because there is nothing you can plug in for these x's to ever make 5 equal to 7, because that's a completely different number. So I'm not going to work any of your homework this time, because I've worked an example like each of your ones. Excuse me, that didn't make sense. I worked an example like each of your homework problems already. You will have 2 questions on your homework, and they will ask you if it's a conditional equation. If it's a conditional equation, you will put in your x value as your answer. And if you come up with one of these other answers to where we have negative 5 equal to negative 5, and so that means there's infinitely many answers, then you'll click that box that says infinitely many. Or if you come up with something like this where it's 5 equal to 7 and that's false, then you would click the box that said no solutions. So I hope you get a lot of practice with this, and I hope it's not nearly as hard as it could have been since you've had some practice with section 2.4. Good luck with your homework, and good luck with your quizzes.